Atomic-6 is an Atlanta-based startup. They're focusing on advanced composites, and their products include satellite solar arrays and something called space armor, which obviously sounds very cool. Atomic-6's CEO and founder, Trevor Smith, is my guest this week. Enjoy. Hey, space enthusiasts, welcome back to another episode of the Space Business Podcast. My guest this week is my friend Trevor Smith from Atomic-6. Welcome, Trevor.
Thanks for having me on. I'm excited to be here. I've heard so many of my friends on here, and now I get to be here with you.
I know this was way overdue, and we've waited so long to do this that in the meantime you've decided to start your own podcast, which I also
Yeah.
recommend people listen to, and we'll put the link in the show notes. It's really fun. Trevor is taking people around basically in supercars. So sort of like I think the inspiration was that what's it called? Comedians in cars, something like that.
Yeah. Yeah. Comedians in cars getting coffee, but less jokes and more fast driving and lots of space talk and aliens.
Yeah, that's what we want for space related podcast, right? Like you want to drink coffee, yeah, fast driving, thrust, energy, high power, all of that. Anyway, so back to
Yeah.
to this podcast, the Space Business Podcast. So Trevor, the way we usually start is when there's an entrepreneur joining as a guest is for the entrepreneur to give an elevator pitch on what you're doing at Atomic-6, please.
Sure. Totally ready to come out of the gate. No prep work needed. So at Atomic-6, we build advanced composite structures to enable mobility from ocean to orbit. And our big sort of beachhead as an entrepreneur and startup is in the space environment, because when you make the highest performing composites, you want to put those in extreme and demanding environments.
Okay. And so, as I always say, we're like supposed to be a non-technical podcast. The original point of the podcast was to bring in more people into space economy and not scare them off with a lot of jargon. Could
Yeah.
you take a step back and sort of talk about the sort of the inherent advantages of composites and why we're using these materials versus maybe some previous alternatives when we didn't have advanced composites yet?
Sure. Well, you're very fortunate because I am not an aerospace engineer. I have a degree in commercial real estate, so won't be a problem getting too deep in the weeds. But, in space, as they say, mass or weight matters, right? So the heavier something is, the harder it is to move around. And so when you want to use composites, you want to use things that need to be very lightweight and also need to move around, right? So we talk about mobility. So you want lightweight and the ability to move around. I give the example, a Formula One race car is not built out of steel. It's actually built out of a lot of carbon fiber because of that high strength to weight ratio, which also plays into the space arena because you need lots of high strength to weight ratio structures so you can move around quickly but not be so burdened down with that weight.
That makes sense. And actually coming back to your podcast, a lot of these cars you're driving there when you're doing your own podcast, things like McLarens and so forth. I think they have a lot of these advanced composites as well for related
Oh
reasons.
yeah, the entire chassis on the McLarens are a carbon fiber chassis, like the tub that you sit in.
Okay, so now I have to ask another question we usually ask to entrepreneurs, which is about the origin story. And you just mentioned that your, I guess, educational background at some point in time was commercial real estate. So now, of course, I have to ask, how did you go from commercial real estate to advanced composites?
I think as every good startup starts, over tequila and cigars is where I met my co-founder. But yeah, I got the itch because I grew up racing motorcycles, so I love all things that go fast, two wheels or four wheels. And typically, you see composites in structures and vehicles that go really fast. And so met Blake and got the opportunity to kind of look into composites and had this idea to create very high performance composites, but change the manufacturing process, which had been the problem historically, is how do we get really high performance, but at not necessarily automotive level manufacturing, but closer to that, right? Instead of doing snowflake manufacturing, we want to productize these things almost like Lego bricks, right? So you can productize them, make them the same thing over and over again, and applicable to a lot of different mission sets.
Okay, and so I guess before or when this all started, when people first discovered that composites were a much better material for certain applications, I imagine they were done sort of in a more one-off, probably very expensive. I'm assuming a lot of the stuff probably initially was for defense applications like high performance aircraft and so forth.
Yes, you typically see composites used in those new types of vehicles first, and then it sort of trickles down. And I'll use a car analogy where you see technology in the Formula One race circuit work its way down to the street cars, right? So the same thing in space, you see new technologies built in space and they sort of trickle down into, less expensive vehicles once you figure out that manufacturing, which is how do we get these things in mass production at a quality controlled level that the general public can experience or appreciate.
And so what was the again, without sort of killing our listeners on the technical detail,
Sure.
what was your sort of like high level, the Atomic-6 high level technical innovation to make that happen?
Yeah, the metaphor I love using, we have a glorified muffin pan. You know what a muffin pan is, right? You can make
Sure.
muffins. It's essentially a mold, right? It's shaped like a muffin pan, and that's the shape that you want to make. So we have a very unique muffin pan that allows us to pull more performance out of any given material set. So we are manipulating the raw materials, and in this case, that is the carbon fiber, typically, the resin, which is the glue. And then inside that fiber and resin system, you typically have air that gets trapped in that glue. So you want to squeeze out all the excess resin and all the excess air, really relying on that fiber to do the heavy lifting. And so this unique muffin pan that we have squeezes, for lack of better words, all that excess material out, pushing the composite material towards its theoretical limit. So a near perfect structure, if you will.
Okay, and is that something that you guys came up with at Atomic-6, or did this come out of like university or from like a co-founder, or where did this technology come
Atomic-6, right? So we had this idea, let's make this unique muffin pan, let's cook the composites in a unique manner, and let's see what happens. So as an example, the very first flat panel I made for a large defense prime said, hey, let's see what you can do, right? So I know most people aren't watching, but for your purposes, Raphael, I'm holding up a flat panel of carbon fiber. And so we made a flat panel, and we were within 2% of the theoretical limit for the mechanical properties of that fiber and resin system. So the high water mark at the time was around 80 to 85%, and we were sitting at 98% of the theoretical limit. So we didn't have an application in mind with that. We just wanted to showcase we can make a better muffin, a near perfect muffin, if you will.
So that actually was going to be my next question, whether you guys had sort of the tech first, or you guys thought like of the application first, saying like, oh, we really need this for, I don't know, better aircraft, better motorcycles or something.
It was definitely the tech first, because we started looking at auto haulers, which are the tractor trailers that move cars down the road. We looked at trains. We looked at box cars, so truck bodies. So ultimately, we were like, how can we increase payload and range in vehicles if we lightweight them? So that first 3 years while we were bootstrapping the company, we had the right idea, which was how do we increase payload and range? But we were going after the wrong application. The application we were pursuing was terrestrial through tractor trailers and trains and that sort of thing. But what you see is people are willing and have the budget willing to pay for those higher performance systems in those extreme and demanding environments. So we got our very first SBIR phase 1, Small Business Innovation Research from the Department of now War, to go after space structures. And so that is where we sort of found our first initial traction. Oh, there's a customer in an extreme environment that has a budget and has a need and willing to pay for these really high performance structures. So that's sort of what put us on this trajectory for space and defense.
So that's interesting. Let's just spend a couple of minutes more on this sort of process of narrowing down towards the target customers and applications, because it's probably not an uncommon, let's call it, problem that space or space type innovators have, that like we came up with this technology which seems really cool, but like what are we actually going to do with it? Now, was that so? Did you guys go about it like systematically? I guess you said it took 3 years, or was it sort of a little bit of hit and miss and then like random, or like how did that process actually look like?
So a lot of customer discovery, and I encourage all these year zero founders to really dig into the customer discovery first before you go spend a lot of time and effort building your widget or your product, because you want to make sure there's money somewhere and a customer willing to pay for that thing. So in our case, we weren't coming out with a product per se. We had a manufacturing capability and needed to find where to point that capability for the right product, right? So that's that first 3 years of bootstrapping before we raised our first round in 2021, was doing all that customer discovery, interviewing tractor trailer companies and 18-wheeler companies and all those types of terrestrial applications that kept pushing us towards more extreme environments and we finally landed on space and defense, which is where we got that first phase one. Does that answer your question?
Yeah, it does. But just kind of pulling on a thread a little bit. So in terms of the value proposition to the customers, was that pretty clear and sort of stayed the same from the beginning? And I know something maybe like you mentioned, like the characteristics, like higher fiber to resin ratio, or was it something that kind of through these interactions with the customers got refined and until you really had hit like a sweet spot, like very crisp value proposition that you could present, hey, we're adding this specific value to you guys?
Sure. So, with technical founders, they tend to really sales pitch their technical capabilities of
Oh,
their
yes.
product. The customer doesn't necessarily understand how to translate that into value for themselves. And so what you have to do as a founder is understand how to speak the customer's language. So in the case of the, trains, right? We were looking at truck sets, which are basically the axles that hold the wheels on the rail car, right? We could save a bunch of weight. What is the return on investment for that product, right? So they didn't care about fiber to resin ratios or void content. What they cared about was the ROI on that product, right? So that product was a 50-year product. It's supposed to stay on the train, on the rails for 50 years. At the price point we were looking to sell it, they would have a 2-year payback on their money that invested, and then a 48-year, value in that product, right? So you have to speak to that customer in the language that they understand.
So did you end up learning more about railroads than you ever thought you would?
I did learn a lot about railroads, and I learned that our competitors all started in the early 1800s, and it is a highly regulated environment, which was why it was very difficult to break into, which is also why we pivoted away from it, because it was such a high regulatory burden to get into.
Okay, so you went through this whole process, and eventually, I take it, you came out that sort of the key market application customer is space and defense, right?
That's the first big one that we identified. Yeah.
Okay, and so let's go a little bit more in the weeds on that. So, what specifically, like, what are like your top applications that you're pursuing for the space and defense markets?
Sure. Love talking about this. So the big unlock as a company was identifying a product that we could sell, right? So if you are a services-based company, let's insert a composite manufacturing shop, right? There's a customer saying, "Hey, I need this wing. Will you build this wing for me?" And then they make the wing and they send it off. That's a services-based company. So that wing is not their product. They're making that product for their customer, right? So it's the customer's product, right?
Yeah.
We found two products actually in space that would work for a lot of customers. So instead of having, SpaceX, they're on your background there, SpaceX saying, "Hey, we need a solar array," we came up with a new type of redeployable solar array system that was productized, kind of like those Lego brick manufacturing. And it's adaptable to any spacecraft, space station, and we even have versions for the lunar and Martian infrastructure. But that's how you get to that large scalability, building things out in an adaptable way so you can apply that product to lots of different areas, right? So it's like windshield wipers. They go in lots of different cars, but it's basically the same thing, right? The other product,
Go
go ahead.
Yeah, sorry. No, go ahead. You finish first.
Yeah, so that's power. Everyone needs power in space. You need solar arrays. I haven't seen a satellite yet that didn't have solar arrays. The other side of it, more and more, you're familiar with the Kessler syndrome. Debris is obviously accumulating in low Earth orbit and other orbits. So we've come up with a product called Space Armor, and you can guess what it does. It bulletproofs satellites, right? So the United States Space Force sent out a direct to phase 2 opportunity. We submitted for the proposal, and we built a new type of micrometeorite and orbital debris shield, or space debris for short, but it was the thinnest, lightest debris shield that Space Systems Command and Space Force had ever seen before. So it's an all composite shield that stops debris coming in at Mach 21, or about 17,000 miles an hour, with no post-impact ejecta. What that means is once the impact hits, there's no fragmentation after that impact other than some gas and particulate. But today, and historically, what has protected the ISS is what's called a Whipple shield. Those Whipple shields are multi-layered metal plates for the most part and have some composite in them. But when they get hit, thousands of pieces of metal come out of that impact.
So you actually make it worse in a way. So
you totally,
but you kind
totally
of
make it
screwing everyone else
worse
because there's like additional debris around.
You totally make it worse, right? Like you're driving down the interstate and your front bumper, comes off, and then another car hits that bumper, and then you get more debris and more debris.
But yeah, or if you I don't know, you're wearing like a bulletproof vest, somebody shoots at you, and the bullet actually like kind of goes in like fragments and kills people like around you.
That's exactly what happens. If you go to our website, there's a great video on there with a side-by-side of space armor and a monolithic block of aluminum. What you see is the impact on space armor is just kind of gas that comes out. On the aluminum, there's a 3 millimeter ball moving at Mach 21 that comes in and hits, but more mass, more aluminum actually comes off of that shield than originally hit it. So you're causing more debris by protecting the satellite, and debris actually comes on the backside, potentially damaging your own spacecraft. And then all the debris in front on the strike face, as we call it, goes out and messes up orbits for everybody else.
And so let's actually talk about those both of those products because they're both interesting, space armor and the solar arrays. So on the space armor, so just to recap, so was that kind of you guys had the idea, or was there sort of a specific customer pull?
It was a customer need. So, right, the government pushes out ideas and topics that they would like to see developed.
Yeah.
And so Space Force said we'd like to see a new space debris
Okay.
shield developed. So we applied for that. And the same thing with the solar array. They said we would like to see a new type of solar array built. So we, through multiple SBIR contracts, we came up with a system that was really unique and has this redeployability capability in it, right? So we can actually deploy and retract and then redeploy the solar array, which is really, really unique to the system. And because we've built it nearly all composite, we've gotten rid of hundreds of failure points across these, hinge mechanisms, and the pantographs, or I like to call it scissor lift because it kind of goes up like a scissor lift, but you're eliminating all these metallic failure points in a system, making a much more reliable solar array. So what matters in the solar array business is not, debris like we were just talking, it's watts per kilogram. So how much power to how much mass. So our systems are pushing 200 to 250 watts per kilogram, which is a very, very high watts per kilo metric, while being built in a Lego brick manufacturing method that allows us to be very cost competitive for what these customers need. And it's actually why we've put over $4 billion in bids out to mega constellations just for solar arrays. Yeah, lots of mega constellation satellites going up.
Yeah, I was gonna say, I mean, as you said, I mean, except for maybe some really funky exceptions more for interplanetary spacecraft, I mean, pretty much every spacecraft has solar arrays somewhere.
Right.
The projections, obviously, for the numbers of spacecraft between, I mean, mega constellations, obviously, some of them build their own stuff, but also like more and more countries wanting their own constellations. I mean, we now have some very aggressive projections of satellite numbers over the next few years out there, and yeah, they all need solar arrays. So what's the status of that product, and how has the reception been?
Well, I just mentioned $4 billion in bids, so it's gotten a lot of attention. We have not flown yet. First flight will be Feb 1 of next year, so 2026, coming up in 4 or 5 months. So we have what's called a tactical funding increase contract from the United States Space Force. That TACFI, for short, is to get the solar array system through flight qualification. And we are going through that process now. And that same flight qualification and TACFI contract, we got a second one for space armor. So both space armor and Lightwing, as we call our solar array system, are going through flight qualification now.
And the solar array, what size satellites are those for?
So the deployable systems that we sell, you look at as small as around 500 watts is where it starts to make sense. Up to, we're quoting 12 and 15 kilowatts, and even 300 kilowatt systems. Those are more like the space-based solar power, the orbital data centers, or like the lunar infrastructure. But typically that, LEO constellation is going to be somewhere between 2 kilowatts or 2,000 watts of power up to like maybe 12 or 15 kilowatts of power.
Yeah, so actually we're talking sort of like small sats and up, basically.
Right.
That makes
yeah, not CubeSats, but
yeah, certainly not CubeSats. But I mean, that's fine. I mean, that's where sort of the most interesting part of the market is, I think most people would believe. And so I mean, speaking to spacecraft manufacturers, sort of in my day job, I mean, I think I've heard several times now recently that when people talk about potential pain points of like spacecraft manufacturing at scale, like they're certainly mentioning the solar. So I'm actually not sure if the solar array part or specific parts of the solar array supply chain. I think maybe it's solar cells, but is that something you've seen as well? Are there pain points and
absolutely. So the Space Force says that the number one supply chain priority they have is solar arrays. It is the biggest bottleneck. It's the hardest to make, and arguably, it's usually the largest line item on the bill of materials for a satellite, depending on what your payload is. But typically, it's somewhere around 20 to 25% the cost of the entire satellite. So it's the most expensive thing you're paying for. It also has the most problematic supply chain currently, right? And then on top of that, you mentioned the solar cells.
Yeah.
That's becoming addressed more and more. There are more startups working on the solar cells. So to be clear, we are actually solar cell agnostic. So we get to adapt our system to what our customer's mission set needs. So if you have a 2-year mission in LEO, we can use very cheap solar cells. If you have a 10-year mission in geosynchronous orbit,
different types of solar cells.
Yeah, you're going to pay for those very expensive multi-junction solar cells that have that high efficiency and low degradation. But because we are agnostic to the solar cell, we can address the spectrum of mission sets across the entire space industry, something that's really unique to that as well.
Okay, so you're basically, the solar cells, they're just a supplier to you. You guys integrate the whole array and basically build that subsystem.
Correct. So when a customer says, hey, I have a 5-year mission in LEO, here's the orbit I'm flying, I need 2 kilowatts, give me a couple of cell options and show me what that looks like on your system. And so when we deliver a solar array to the customer, we send them everything except the solar array drive assembly. That's actually where we match up to the chassis or the bus, if you will, of the satellite. Right. So we are agnostic to that, and we can match up to anyone's solar array drive assembly.
Okay, so the solar array drive, solar array drive assemblies, I think sometimes also called the solar array drive mechanism, I think. Whatever. SATA, SADM, whatever, that thing. Yeah. I think basically what it does, it sort of like moves the whole array, right? Can like
correct. It turns it,
whatever. Right. So you have it's in the most advantageous position it could be. So that you don't do, but the customer basically does, and
the customer can supply it, or we can advise and consult with them to pick out the proper SATA. But that's usually where we see the line of demarcation, right? The handoff to the customer. We're going to match up to that SATA, and from the SATA on into the bus, the customer is responsible for. But from the SATA out, looking out to that power system, that's all of us, right? So we have the deployment mechanism. We do all the wiring, all the structures that go out with it, and then we match up the solar cells onto our structure depending on that mission requirement.
Okay, and so in a perfect world, if this product catches on, and so you actually let's say you got big contracts, and so you have to produce suddenly hundreds of them a year. That's obviously like another sort of challenge that startups very often face, at least the startups that survive that long, right? That suddenly you go from sort of like, hey, I have cool technology, prototype, customers understand value proposition. Oh shit, now I have to like make 100 of those.
Yeah, it's funny you say that. So ironically, I kind of wish that the bids were smaller that we were sending out. Right. Like I wish we were sending out, 20, 30, 50, $100 million bids. But these bids are high 9-figure and low 10-figure opportunities. As a 12-person startup, you're like, okay, if you're looking at a staircase, I'm on the first or second step, and somehow I have to get to the second floor in one leap, right? How do you do that? So fortunately, and you've had him on your podcast, my chief operating officer is Christian Carpenter.
He's great.
Helped design the propulsion system for Starlink and helped lead the manufacturing team that put the first 1,400 satellites up. So he knows how to build large production facilities. And we are in the process of designing a full production facility that can address 2,000 satellites per year, give or take the power requirement, but somewhere between 5 and 10 megawatts of power. To put that in a reference point for you, a few years ago, 2 or 3, if you excluded Starlink, the entire global demand for solar power was around 2 megawatts. We have 5 times that global demand in our current pipeline. That should show you that the industry says, okay, SpaceX and Starlink have figured this out. Constellations are possible. Now you mentioned, global national companies and nation states need their own sovereignty. So they are going to build their own systems, and they know it's possible because of what Christian, my COO, and his team at Starlink did.
Yeah. So it's an interesting and important inflection point for Atomic-6, and again, probably for other companies in similar positions, that you guys obviously, like you said, you're going to need a new production facility that obviously will require some probably reasonably significant investment, which again, I mean, you're not the only ones, right? It's like, that's why people like, Apex satellite manufacturers are raising these quite big rounds because suddenly they have to make a ton of stuff.
Correct. You go from 0 to 100 miles an hour, in like a few months, right? So, but it is doable, and Christian's had that experience, fortunately. And it's a really exciting time for the team at Atomic-6 because of this new space race, if you will. Yeah.
Yeah. So, okay, so now we talked a lot about the solar arrays, but so coming back to space armor, what what's the plan there? How has reception been to that? I mean, because that obviously falls into the larger bucket of space debris, and that we could talk hours just about that
Yeah.
and how different people view that. But
So I have to dance a fine line here because one of the characteristics and capabilities I have not mentioned yet, it actually stops directed energy weapons. So
okay,
high power lasers, in addition to stopping debris. And we've built a version that allows for radio frequency permeability. So you can now have a radome in space, which has never existed before. There's never been a structure, to our knowledge, that has stopped space debris and allowed for that radio frequency RF communication through it. So that is something that is extremely exciting. There are a few defense primes that I will not mention that have already paid us for space armor. They're doing some testing now, but you want to apply this to high value assets, mission critical assets, and then also assets that are flying in orbits that have a lot of debris, right? So there's a lot of debris in low Earth orbit in certain orbits of LEO. So you want to apply it there. So not every Lightwing customer needs space armor, but every space armor customer will need Lightwing. So I look at it kind of like that. The bigger revenue opportunity is the solar array because everyone needs power. And then certain mission sets that are really critical also need protection. So we're offering both power and protection to the space industry with two very, very unique, first of its kind, if you will, products.
yeah, but I wasn't aware what you mentioned there about the sort of defense against directed energy weapons as well. So, I mean, let's face it, there's adversaries who would have probably no issue using those if they think they can get a benefit out of that. So I'm imagining, without wanting to cross the line here into clearance territory, but if you had something like, hypothetically speaking, spacecraft hosting Golden Dome sensors, you probably
Right.
want them as resilient as
Well,
possible.
you think, you've heard, hey, never point that laser at someone's eyeball. You could hurt their vision, right? You
Yep.
hear that all the time. Well, you can draw a quick line into space. You look at communication systems. If you pointed a laser at a communication system, you could blind a satellite. But because of our space armor capability, we can stop that laser from blinding the communication system and still allow that comm system to get their transmission through it. So you're exactly right, and I think it will be more and more of a thing, and it's very exciting to see what we can go protect. Not exciting to see weapons in space, but you never know what's going to happen, and you want to be prepared for that.
Yeah, absolutely. So, okay, so you have two products we talked about here, the Lightwing, the solar arrays, and the space armor. They both look very exciting from what I can tell. So, yet another question, which I think is something that many entrepreneurs face. So, you're in this fortunate situation where you got like two really exciting looking products, but management bandwidth, capital is by definition always limited. How do you balance that, sort of like where to lay the focus?
I think you focus it on where your sales pipeline is telling you to focus it, right? You focus it on where you can make the most near-term revenue and where you can make the biggest impact. And I think that is, both products are very compelling. The larger impact is the solar array system. So in addition to that, because we've designed this solar array architecture to be deployable, we not only can deploy solar arrays, but we can deploy other things as well. So we have a mission going up with Auburn University where I call it a glorified selfie stick. So this deployable mast goes out and you've got a camera and you can look back at the satellite and you can use that for a lot of different things, right? You need to do some diagnostics, see what happened. Did you get hit by a debris somewhere? Are you in the right orientation? You can use that camera. Also, heat, ironically, is a problem in space, right? So we're building these
Sure.
bigger power systems. You've got to get the heat out of the spacecraft. All right. Ironically, space is cold, but it also gets really hot. This same system we haven't built this yet, but should also work for deployable radiators. So you can push deployable radiators out to get rid of that heat that you're generating through these higher power systems. On top of that, you've got phased arrays, which look a lot like a solar panel. They're very flat, but you could see a system where it deploys out phased arrays, increasing that capability for that phased array communication.
Yeah. So I mean, on the radiator front, and again, for sort of like non-technical people in the audience, that is literally to kind of dissipate. I think that's the right word. The heat in space, where there's no convection. Like you can't just, it's a vacuum. You can't pass it on to like the air around because there's no air around. So yeah, the way to go is radiators, and then you need bigger and bigger ones depending on how much heat you have to dissipate. So are you watching the whole like orbital data center craze? Is that something that's near term in your sort of field of vision, medium term? I don't know. How do you look at that?
Very much watching it. And we released one podcast on my podcast. We released one episode already where I was with Philip, the CEO at StarCloud.
Okay.
So StarCloud is building data centers. And I'm glad you brought that up. The first public space mission that we announced a few months back, we are powering the first space orbital data centers around the lunar surface. So Lone Star Data, who's already been to the moon twice with Intuitive Machines, is going to be putting up a small constellation in lunar orbit with their data centers, and we will be powering that system. Current first launch, I think, is early in 2027. So I'm very much watching the data center play because, as you know, they need a lot of power, and they will also need to get rid of that heat generated from that power, and that comes from the deployable radiator piece of it.
Exactly, because I mean that's a huge. I mean both power and the heat are a huge issue for data centers on Earth. On Earth, we just solve this in different ways, which we can't use on Earth. In space. So. Okay, interesting. You mentioned the launch there, so let's maybe talk a little bit about your sort of next milestones. So just to recap, when are you launching when's the first demo missions for these products?
The first will be February 1st, 2026 from Vandenberg Space Force. Vandenberg. You're welcome to come with us if you want. And it won't be the full deployable system of Lightwing. I call it a pop-out panel, but it's basically a flat panel with some solar arrays that will pop out from the spacecraft and generate some power there, just as a first sort of demo mission. And we're hoping the full like 1 kilowatt system of Lightwing will fly around October of next year. That one's not under contract yet. And then Space Armor, we are hoping we have multiple opportunities next year to fly that as well. So looking to get both of these products up and space qualified at some point next year.
Okay, cool. And I should have asked you to kind of describe the product just in a little bit more detail. So because we can't show stuff, or not everyone has the
Sure.
This is video, right? So the Lightwing, how should I imagine that? Is that sort of like a boom, an extendable boom, and then the solar cells get dragged onto it, or like what does that actually look like?
Kind of like a Venetian blind or an accordion, right? So like there are two masts or poles, booms, that will flank the solar arrays, and then in between those two booms, you have these solar backsheets with the cells on them, and so the deployer will deploy out the booms. As those booms come out and they roll out, it pulls that accordion or the blind set with it and deploying that solar array system out. So it just sort of unfolds kind of like a sticky note stack, if you will. Like if you pull the sticky note up, it all kind of folds out like an accordion.
Gotcha. Now, the other question just came to my mind. So, sort of the intersection of your products, space armor against space debris, and the solar arrays. I mean, especially like with power requirements going up and these solar arrays becoming bigger and bigger, that's probably going to be the highest surface area of a spacecraft almost. Like that's kind of by definition going to be actually the most exposed to space debris, right?
Absolutely.
Do we actually have a way of protecting that, or is that? I assume that's really difficult, right? We just accept that, don't maneuver out of the way. We're just going to lose like X% of the solar cells.
Well, if we protected it from debris, we'd also block the sun, and you wouldn't be able to power the system. But like you can look up pictures on the International Space Station where there are tiny micrometeorite holes in the solar array backsheet. And so if you wire the modules up correctly, if you do get a debris impact, you just lose one module. You don't lose the whole array, right? It's just like a tiny little BB hole in the structure. So it shouldn't be that big of a deal.
Yeah, that's how I figured we'd do it. Okay, cool. Coming back to your sort of milestones, well, actually, let's look a little bit further out. Like, if all goes well, like, your IODs, your orbit demonstrations go well next year, you actually scale up, you win some of these bigger contracts. Where do you want to go with the company, like in, I don't know, 10 years time?
I mean, I think the easiest way to sort of relay our goals for the company is, we're building out the power grid for space. We're not making a single one-off solar array that is unique to any certain mission set. We're literally building out the circuitry and the if you could go back and look at Westinghouse, right? Westinghouse built out, circuits, city grids, city power grids, right? So that's how I look at Lightwing. We're building out the power grid for space because we're adaptable to any spacecraft, and also building these what's called lunar vertical solar array towers, which will vertically deploy on the lunar surface, gathering a lot of power, right? So that's how I think about Atomic-6. We're building out the power grid for space, and then also building out that protection at a certain level. Not everybody needs it, but we're also offering that the protection level for space as well. But we're essentially a utility provider, right? We're a utility provider for space.
Gotcha. Okay, changing tack a little bit since we only have a few minutes left. So some questions we always like to ask towards the end. So one is, some of the entrepreneurs we interview, they're sort of in non-standard, let's call it ecosystems, like they're not in Silicon Valley or LA.
Yeah.
You guys are based like in the suburbs of Atlanta. Do you want to talk a little bit about how's the Atlanta ecosystem?
Well, it's good because I live on an airplane, so I can get on Delta flights pretty quickly. But from a space ecosystem, there's not a lot here. There's us and a handful of others. Hermeus is down the street from here. Yeah. They're a customer of ours. We're actually building the hypersonic radome to go on their aircraft structure, but would love to see more space companies in the Atlanta area. And with this production facility that we're building, we may not do it in Atlanta. We may put it somewhere closer to that space economy, that space environment, whether it's down by the Cape or out in Texas, but we're looking at different sites for that to go build that. So, unfortunately, it is not the bustling space ecosystem that you see in Colorado or El Segundo outside of LA. So we're looking at what that might be. I wish it was bigger, but for space specifically, it is advantageous to be close to launch sites, and we don't have a launch site here in Atlanta yet.
Or I guess by induction for you guys, like with those products you're talking about, you probably want to be close to like the spacecraft integrators, right?
Correct.
Okay. Who then sells then should be close to launch sites. So so there you go.
Right.
Okay, cool. And then you obviously, apart from Atomic-6 and all of the things we talked about, you're obviously, excited about space in general. You see a lot of things in space. Actually, we should kind of point out from transparencies for listeners, like both Trevor and I are actually mentors at Creative Destruction Lab Space Stream, which I believe is the, if not the, then one of the best space startup accelerators out there. We'll actually both be there next week for the first session. What else excites you, if anything, in commercial space?
Well, being in CDL with you is very exciting, and having gone through it, and I've been on both sides of the table because I went through it as a venture or a startup, and now came back because I couldn't get enough of it as a mentor. That's always exciting to see. But you mentioned orbital data centers. Very excited to see how that plays out. Seen a lot in the news recently. Like there's
Jeff Bezos mentioned it.
Bezos mentioned it. Voyager just mentioned it a little while ago. Eric Schmidt mentioned it, right? It's such a drain on the Earth resources that we have. I think if we can make it happen, then we should absolutely do it. And for the longest time, Christian, my COO, was a non-believer of these ODCs, orbital data centers. He's a hard customer to convince, but he's convinced that they will be a thing now. So I think that is probably one of the more exciting things, to see these orbital data centers move into space and, kind of free up a lot of these resources that we have on Earth. So that's cool. And then, humans on Mars. That's, it's in your name, Earth to Mars, right? Like, I'm super excited to see the first human on Mars, but even sooner, I'm excited to see a permanent base on the moon and look forward to powering that system. So excited for that.
Yeah, humans on Mars, like Starship launch later today. Fingers.
Oh, is it today? I gotta watch it. Yeah,
I think it's tonight. Yeah. Well, tonight, like Eastern/Central Time.
Well, do you see my Starship I have behind me?
Yeah, again, sort of for those of us who are actually watching on video, like, there's a very nice Starship model with some neon lights on the bottom. I mean, that's seriously cool. And Trevor, final question is always the same. Science fiction, any favorite science fiction movies, TV series?
Oh, yes. So my latest and greatest is the Bobaverse. Christian, my CEO, actually turned me on to this. There are 5 books. You can listen to them all on Audible. It is really, really kind of far out there, but also uses technology from today, so you can kind of tie the bridge.
That. Is that the one? The first one is something like "We are Legion, we are."
Yeah, we are Legion.
Like
we are Legion.
Von Neumann probes.
It's all about von Neumann probes. It's all about von Neumann probes and how we can explore the galaxy through replicants, AI replicants of ourselves. Pretty fun to read and listen to. I just listened to it on Spotify.
Yeah, it's a funky concept. Like you said, it's an idea that came up many decades, well, von Neumann, many decades ago, and it's not entirely implausible. Yeah, that's a good one. I don't think anyone has mentioned it before, so thank you for that. Trevor, it's been a pleasure. Thanks for coming on. Best of luck with everything at Atomic-6, and I look forward to seeing you in a week at Creative Destruction Lab.
Thank you for having me on. It's always a pleasure to hang out with you and chat, and I'll see you next week in Toronto.
Thanks. And that's it for another nominal episode of the Space Business Podcast. And once more, if you enjoyed this episode, please leave us a 5-star rating on your favorite podcast platform, such as Apple or Spotify. You can follow us on Twitter at podcast_space. We're also on LinkedIn under the Space Business Podcast. Lastly, if you have any feedback, including ideas for guests, and that may even include yourself if you have an exciting space story to tell, or interested in becoming a sponsor, or really for any other suggestions, you can drop us an email at spacebusinesspodcast@gmail.com. Thanks so much for listening, and see you for the next episode.